FDP to make it a real success. Your words would definitely put the correct flavor to this FDP. And participants, I would like to tell that the money was continuously traveling. He landed just uh, an hour or so before reached his home, and we are really very mm, keen to hear for you. And I'm personally very sorry to keep you always bothering and disturbing you and requesting you to means, and you even agreed also that despite of your busy schedule today, Mani, no words can express my thanks for you to join today. I can understand that how difficult will it be for you, but I know that the session would be definitely very helpful for all the participants. And without your session, it would not have been a fruitful FDP for all of us. So, Ritu, I would request one of the participants, I think Ritu is there, to introduce Mani formally, and then Mani can begin the session.
Good evening to all. It is my pleasure to welcome you all to the last session of 1 week AICT Atal FTP on exploring AI using IBM Watson and Google Colab. We are honored to have with us an esteemed speaker, Dr. Mani Madhukar, a distinguished expert in edtech innovation and a key figure at IBM India Innovation Center for Education. With over 18 years of experience, Dr. Madhukar has a proven track record in academic program management, cloud pre-sales, electronic content management, competency development, and mentoring setups. He holds a doctorate in computer science and engineering from Banasthali Vidyapeeth and an executive program in management from University of Virginia. As part of IBM, his expertise spans various domains including generative AI, data science, cloud, blockchain, Internet of Things, and IBM Watson. He has published various research papers in national and international conferences and journals, including essay publications. Beyond his academic and industry contributions, he also serves as an advisor to incubation centers, an expert on curriculum design, and a member of academic councils and a board of studies at various universities, including AICTE and NITTR, and many more. He also actively mentor online communities in blockchain and cloud technologies through professional forums and workshops. Today, he will delivering a session on exploring IBM Watson. We're looking forward for an engaging and informative session. Now, I invite Dr. Mani Madhukar sir to commence the session. Over to you, sir. Welcome, sir.
Thank you, ma'am. And it's been an honor and pleasure to be here. And Mayank sir, thank you for those kind words. It's always a privilege to be together, standing together with Gurukul Kangri University, and in particular you for the very initiatives that you drive. So it's been a long journey together. I think more than a decade. We have been working and collaborating together. So really appreciate and thank you for inviting me here today.
Thank
Um, what I would actually like to start with is I've seen that by this time as we talk, you would have already, been through multiple sessions of various speakers and in last few days, and I'm sure that they would have taken you through various, they would have taken you through various uh, topics, including, I had my colleague also who had joined. So I see, a lot of topics have been covered in last few, days for you, and which is really great because, the more the spread of the topics, I feel it's really helpful in terms of getting knowledge across the board, and then we can pick and choose which are the areas as a faculty we would like to dive in, and we would like to sort of dig into it deeper and sort of develop competencies in. For the topic today that I I had something else in mind, when I had this session scheduled on day one, but I understand a lot of learning has already happened in last 5 6 days, and hence I think I will move on a different topic for this session. And um, and actually I'll try to sort of shuffle between multiple things in my conversation with you today. Okay. And I will again focus on various AI services on IBM Cloud, and then we'll dig into Watson for a while. But before I go into that, I'm sure most of us in this session now would be able to appreciate that. I'm sure you are all into teaching, and you had been into the learning life, so uh, you would be like 28 plus or something, right? From a age group point of view. So when AI, you would have seen a few years back, AI would have been like a layer on top of a existing application. So we used to talk about something plus AI, right? So something in the sense there was a base product, and then AI was on top of that, right? If you see here, so the approach was this plus AI, right? What currently the way we see it is, it's absolutely different, right? What we talk about is AI plus. We're basically going beyond what AI could actually do. And that's why you see there has been a lot of conversation around traditional AI versus modern AI, right? Traditional AI was all that we have been knowing all these years, traditional, all that approach of having an ML models and all that. What we typically are moving towards is more about generative AI, right? More about RAGs and all, where that's what we are typically moving towards, right? And we are moving towards automation and of AI, right? So that's something which is very, very, very critical. If you see from next few years point of view, because that's where the enterprises are moving towards AI plus, right? Something which is beyond that thing. And I can tell you for sure that last year, 2024, 2025, the most of the experimenting part is already over. Okay, what enterprises are working towards is scaling and optimizing the models. And as we go forward, it will all be about innovation on top of those models. And you would have seen the kind of hype, Chat GPT actually created. It really democratized generative AI, if you ask me, right? See, the technology was very much there even prior to that, but the way it has brought the technology to the you know everybody keeps talking about it, right? That has all happened because the way people have seen Chat GPT, interpreted it, seen things coming in media and all of that, right? So that has really made the technology very much a household, so to say. Okay, now this is in terms of how the market is really evolving. You would have seen the government of India has actually a India AI mission, right? As part of that, they are putting together an infrastructure which is GPU powered, which is solely aimed at promoting research and innovation in AI space, right? So that means there's a lot of market in terms of not just learning, but also in terms of practicing and more in terms of research. We'll come on to that piece in a while. Okay. Um, so I'll quickly move, from here. Before doing that, I'll take you through this piece, right? Um, so AI has been now there. We are moving towards what we call it as Gen AI, right? But again, what we are really looking towards is how do we make this Gen AI as a trusted Gen AI, or for that matter, AI as a trusted AI. Few years back, you were hearing about ethics in AI or bias-free AI, right? And now we're talking about trusted Gen AI, and then how do we amplify the return on investment of whatever application that we are actually working on. As far as IBM is concerned, this is the IBM's generative AI technology landscape, right? Right from the entire tool set which is available on hybrid cloud powered by Red Hat OpenShift, right? Red Hat OpenShift AI, right? There is basically layers which are actually moving upwards from a user point of view, right? So at the bottom, you see there is a cloud AI tools. Then on top of that, you have data services, which are basically used to define, organize, manage, deliver data to train and tune models. And I guess you already had seen a flavor of Watson X the other day with my colleague Shikha. And then we basically are moving towards adding, the data platform on top of that, which is all the foundation models, including the Watson X, which is IBM's generative AI platform, including three major pillars: Watson X.ai, Watson X.governance, Watson X.data. Now, why are these three separate and important? Because they need to take care of individual things. Now, I'm currently working with a university who are looking to set up something into AI ethics. Now imagine a university actually setting up a complete infra for researching around ethics in AI. Now we all know that there are so many frameworks available for implementing ethics in AI, but having it as a core research area was never there. That is something which is people are now realizing that AI is okay, but then we need to look beyond the AI and really. So there are a lot of problems statements around from a research point of view into this particular segment, right? And then you have various SDKs and APIs integrations, and then on top of that, various IBM services like Watson X Code Assistant, Watson X Assistant, Orchestrate, and Orders. So you can see that, right? Uh, uh, these are the various broad landscape that IBM offers in terms of a generative AI point of view. I'll basically move away from here, and I will actually like to take you through something else. Now, where are we, from an overall adoption point of view, right? So if you see this infograph, that basically talks about how is the level of expertise in AI or AI related domains, how the scarcity in this is really harming across the globe. It's not just India, it's across the globe. By the way, India is the leader in terms of AI adoption in enterprise landscape. The latest case study, there's a survey which talks about that India has been able to successfully implement something like 59% of AI in enterprise work solutions, which is globally it is the best, right? So we have been at the forefront of adopting AI into applications, right? Having said that, this is again a established fact that there is a shortage of manpower. There is no denying that globally there is this problem, right? And being the most the kind of population that we have in India, uh, India is the most suited as a geography, as a country, in the as a country which basically can provide the workforce globally. So if you would know, there is an initiative that we've been recently working along with, UGC and others, and Niti Aayog, we were working with, where we're looking to, train workforce for global requirement in Indian universities. And a lot of bodies in India are actually working towards that, including NSDC and others, right? Wherein we are looking to actually not just have technical skills created within the universities, but also create, others secondary skills, whether it is in terms of language or in terms of culture, other things as well from a global other countries' point of view, right? You might have seen how we have recently catered to requirements in Israel, in Germany, and so many other countries, are queuing up to India in India to basically create workforce here. Imagine, right? US is having a requirement of accountants in big number. Accountants, right? And our graduates, our commerce graduates are looking for jobs here in India, right? What if we could have just taught them about the system there, right? How the taxes are calculated, how is everything happening there, and they could have been actually a good fit for the jobs there, right? Similarly, there are plethora of opportunities available for which we do not have people, and hence, as an educator, as a faculty, your role really is, really increases a lot in terms of taking these technologies back to the students so that they can leverage and they can be groomed for the job roles which are there today and coming up for tomorrow. Okay. Okay. So today I'll basically be sort of talking more about um, from a cloud perspective. So I'm right now at, I'm sure you are familiar with this. I'm at IBM Cloud UI. Okay. This is my dashboard. And I'm sure you are familiar now by this time that you have hundreds of services available in the catalog there, which you can leverage on across multiple um, sections, right? Multiple categories. So right from compute to containers to networking, storage, AI, ML, analytics, databases, IoT, migration, security, mobility, there are like hundreds of services available for which, you can actually create instances. And being a academician, you also actually get access to IBM Cloud at no cost. Not just access to IBM Cloud, but to a plethora of software as well, licenses as well, at no cost for you to play and get acquainted with, right? So today, since we are focusing on AI ML, I'll actually dig into this piece. And you see this, we were just talking about on the other slide, what are the various services available, what's an Next Assistant, what's an Extra AI Studio. And then there are some third-party services also available. For example, right, there is this service available from Blue Sky Creations, right? There is some service available from Cognitive View, right? And there is one from Bespoken, right? So there are multiple services available. There is actually an annotator for clinical data also for somebody who's doing a research into allied streams, right? They can actually make use of this service to analyze text and extract medical codes for various medical procedures, right? And then there are, a few more third-party services like Crushbank, right? Cerebral, and then, of course, you can see there are IBM services there along with that, right? Knowledge Catalog, Knowledge Studio, what's an Xcode Assistant, Neural Seek, which is from Cerebral, and a few more services. So depending upon what area you're working on, you'll find something which will be a good fit, for you to work upon. Not just these cloud services, you also can get access to a few data sets in very niche areas, which you may not be able to find otherwise, which are available through the Skills Build platform. You might have seen the other day, during the demo. So there is actually a repository of data sets which are provided under ODL, Open Data License, which you can actually leverage and, work in your this thing. So these are the various AI ML services. For the sake of brevity, today we'll play with a few services here. Okay. And so I'm actually looking for, so what I'm going to do is I'm going to make use of a few services today. One of which is Watson Studio. Second of which is Watson Machine Learning. And since I'm using these services on cloud, so obviously, we're talking about some ML things, some machine learning models. So obviously, there will be a data set. So if there will be a data set, I need to have a storage as well on the cloud, to store that data set. So I will plug that storage. I'll just plug a object storage onto, my cloud account. And yeah, so basically we'll be, leveraging these three services for this. Okay, I'm sure you already have seen this. So if you see from a studio point of view, this studio actually can launch in two aspects. One is the cloud pack for data, the conventional, AI that you understand, right? And second is the Watson X, which is basically the generative AI platform of IBM, which we just saw, right? So we'll go on to this piece. We'll use the conventional one, and then we'll also see something else. I also intend to talk to you about something which is very recent from a, from a rather, actually, I was studying this, on my on the flight today, and I thought I'll share with you as well. This is something called as chain of associated thoughts, quote, AI framework to enhance LLM reasoning. I'll talk about this when I'll actually talk about the LLM part in my conversation later in the talk today. Okay, so I'll hold this for a while. Okay, so let me go back to my presentation and I'll try to sort of set the context about what I'm looking to do. Okay. Okay, so there are a lot of things, but let me just see where I'll actually take you through. Um, okay, so we are all familiar with model building, right? And this is an old slide that I'm pulling up. And I'm not sure if you've already seen it, but I'll still like to persist with this. So I'm sure most of us are familiar with AI ML in this room, and the typical approach of AI building or model building is like step one, you typically look for the data set for the associated problem that you are looking to find, right? For example, if I am a bank and I'm actually working with a lot of loans, right? I'm basically giving out loans, right? And I'm a bank. Then my immediate worry is that whether my loan which I've given to a particular individual or a company will not be a NPA, non-performing asset, right? I really need to realize that money back from the person I've given it to, right? So for me, data set would be the people whom I've given up a loan and their attributes, right? What would be their attributes? Typical information that we collect while we are sanctioning a loan to somebody. What are those attributes? It would be the name of the person, whether a person is a salaried person or he has a business, right? What kind of revenue, or what kind of salary the particular person gets, right? How many are the, are there any co-applicants to the loan, right? What are the financial liabilities of a person, right? Is the person educated? How many are the dependents of a particular person? Or what kind of qualification, if he's educated, what kind of qualification does the person has? So all of these typically, build a person's credibility, right? For any bank to give him a loan, right? And then we have a CIBIL score you all are aware about, right? So CIBIL score actually also takes into account various other factors along with the financial stability of a particular individual, right? So if that is the use case, then the data set around this will have all these components in it. Okay. So great. So now we have a data set, right? What as a bank I'm looking to do? I'm basically looking to do that for a given number of people, will they be able to repay, my loan, or will they be able to repay the upcoming EMI that they are, that they're supposed to be paying me up? That's my definition of the problem. I'm trying to find whether a particular person will be able to repay my loan, yes or no. That's it, right? And I have a data set, which I've drawn from my bank's customers, right? Now, as a ML guy, what I'll typically do is I'll typically, trying to, of course, with this data set, if this is clean, great. If not, then I will actually have to go into all that data pre-processing and all that. Recently, I came across a very great resource. I'm not sure if you're familiar, but I just would like to let you know that there is some great frameworks for data cleansing. Uh, awesome resources, right? They are like within a few minutes, you'll be able to clean hundreds of GBs of data, right, with those frameworks. And of course, identifying if they are duplicates, if they are, all of that is basically possible. So coming back to the conversation for today, right? So first thing is I'll need to really work with my data set that I have, right? If there are any missing values, the data imputation to be done, so all of that around that. And we know that this is something which is a long task, right? Cleaning the data so that it is good enough to be, sort of having a model out of it, trained model out of it, right? Anyways, so we put some amount of days, months, whatever it takes in terms of getting the data cleaned. Okay. Now what next? So once I have my data ready, right? The next thing is I'll basically try to understand which would be an appropriate algorithm for doing this, right? Whether it's a classification problem, whether it's a regression problem. If yes, then which will be a best possible algorithm to basically go with it. Now we know that there are almost like 20, 30 algorithms available, right? Now, normally it is sometimes it's a hit and try, like, I'll try to do with some tried and tested algo, but then there are more approaches to assess the best algorithm as well, right? So let's say I have basically, drilled into, coding, and I've tried to implement some 10, 15 algorithms with the data set that I had at hand. And I basically created a comparison chart out of it. Okay. And, that would actually take some amount of time for me, right? So a few days, months, weeks, depending upon what I'm playing with. And, and once I have this model trained and I've identified the best fit algorithm, I'll have the model trained. And once I've identified the right model, maybe I'll actually now go and deploy that model, right? And once I've deployed the model, I've put it into production. That is when, it actually, is subjected to the real-time data, right? Various people using it, all that kind, right? And that's when the model is really subjected to various kinds of inputs, right? And that's where we get to realize that the model, which was during the experimentation giving a accuracy of something like 90 plus, has now dropped to something like 70, 72%, right? Which may not be acceptable to the business, right? Because business needs a accurate prediction of whatever we are trying to do, right? It will not make sense for a bank to have a 70% or a 60% prediction of a particular machine learning model, because it's as good as not having a right response to the problem that we are doing, right? And when that happens during production, what we'll do, we basically go back and again go to the drawing board and start to again assess from the previous chart that we had. Okay, this algorithm is not actually giving me a good result. The previous best, what can be the next alternative approach for me, right? So maybe I'll try to do some more ensembling techniques. I'll try to do some other things, right? Again, so point is, I again have to rework on the entire machine learning model that I basically have to. Now, this is where various things will really make a lot of differences. What I'm gonna do is I'm gonna make use of a service here on cloud, which will basically take a raw labeled data set. It will do the data processing on top of it, and all of that. So let me quickly go to my cloud and I will try to show you a small demo of this. My apologies if somebody has already gone through this. I think this is a most low-hanging fruit from a research point of view. So just bring it on again. Okay. So what I'm going to do is I'm going to create a new project. And in case you guys also have a cloud account, and if you'd like to replicate, do let me know on the chat. I'll be happy to support, if you're doing it along with me. So let me just name this project as Gurukul Kangadi Vishwavidyalaya. And I'm not doing anything else right now. I'm simply creating a project over here. Okay. I have already done what I've done is I've created a Watson Studio service and I've spun up this is the instance of my Watson Studio. So you can see over here. And I've just launched it on top of the Cloud Pak for data. That's what I've done, right? I've not used the Watson X approach right now. So this is my interface. I can do a number of things over here. But what I am going to do is I am actually going to I'm going to add a new asset over here, and I want to actually add a machine learning model over here, and let me say that this application is all about BNFS, right? Okay, so I'm just giving it some name. Now it is asking me, where is your Watson X .ai runtime, right? Now I need to associate my Watson X runtime. So Watson Studio is like if I have to explain it another way, it's like a chassis, right? Whenever there is a vehicle getting manufactured, there is a chassis, right? Of course, it comes with a engine, but then I'm just sort of for the sake of explaining it. So Watson Studio is like this huge chassis, right? And Watson machine learning is basically like the engine that powers that chassis, for that matter, right? So what I'm doing is right now I'm sort of associating my Watson machine learning with this thing. And if you see, since I'm actually on cloud, so what it has done is it's given a 8 CPU and 32 GB RAM, allocated it to this to this particular project, the environment, so that I can run my code, right? Okay. Please remember one thing, on cloud, the best practice to use any cloud service is, once you are using something, it's fine. But when you are not using something or you're logging out, please either stop the service or you delete the instance of the service, because it keeps running in the background, right? It's like hiring a auto, and you are keeping the auto running at the in your on your gate without actually traveling into it, right? So I'm quickly gonna create this. Okay. Okay, so it's basically asking me where is the data that you want to play with, right? And I can give this up to 20 GB of a data, for this particular application. So right now I'm using one of these data sets, which is, as I said, banking and finance data, right? So this is a CSV file, though it's a small one, because otherwise it will take a lot of time to get uploaded, right? So right now I've just uploaded this data. It is asking me whether do you want to create a time series analysis from this data, right? So in this case, this is a BNFS data or a bank data. It doesn't make sense for me to do a time series analysis. So I'll say no. Okay, having said that, let's go further. It says, what do you want to predict? So if I click on the drop down here, it basically shows me the various attributes of the data set, right? What are the What's the gender of the person who has taken the loan, whether married, not married, number of dependents, education, self-employed, what's the income, what's the co-applicant's income, loan amount, term, all of that. Now I'm basically interested in whether a particular person would be a fraud risk or not. So, it basically comes back and tells me it's a do a binary classification for that, right? And you should optimize it for accuracy and runtime. Great. So before I go and into it, but I'll quickly do is I'll quickly run this experiment, and then I will come back again to this experiment to show you what can be the possibilities over here. Okay. So just assume that you have given the data set now, right? And again, think of it from your research journey point of view, right? You're a researcher, you just completed your coursework, and now you are looking to identify how do I get it started with the problem that I have, right? So you have identified the problem, you have the data set also as well. But the data set is something that you have to work on the data pre-processing part, right? And then once you have done that, the other things follow as we discussed about some time back, right? So what this is actually doing is, just a moment. So it's right now trying to understand, ingest the data. I'm on home network, so it's not very quick for me, but then let's see. In the meanwhile, if there are any questions, please feel free to put it on chat. We'll be more than happy to take them. Okay, so let me, whatever is happening there, in the meanwhile, I'll just try to take you somewhere else and try to explain, right, this. Okay. Okay. So see this. What is happening here is I'll basically have provided it a raw label data set as CSV file. It'll do all the pre-processing, right? Kind of doing the imputation, encoding, whatever, it wants. Then this will look into and find for me the top performing machine learning algorithm, right? And not just that much, it'll also provide me with so right now it's run the splitting of the data set, if you see there, right? And okay. Okay. Now see, it's basically selecting the algorithm, right? So there are, as I said, there are tens of algorithms available, right? Which can give me the outcome, but then which of these algorithms will be a best fit is what I am really, interested to know, right? So it's basically trying to identify the top algorithms. So currently it will give me top 2 algorithms. That's how the experiment has been configured by default. We can always change that. Okay. Now, for example, it found one of those top algorithms as extra trees classifier, right? So the vanilla flavor of extra trees classifier gives me a 93.8% accuracy. Okay. But what next? So it went ahead and did a higher parameter optimization on top of it, and the accuracy still remained 93.8%. Okay, fine, no problem. So what's trying to do is for each best known algorithm, it will create some pipelines. Okay. Each pipeline, what will do is it'll start with the vanilla flavor and then do a hyperparameter optimization on top of it. Once done, it'll actually go ahead and do a text. Hello. Yeah, it'll basically do a feature engineering on top of it. Once it has done that, so see this, in this approach, it has done a feature engineering on top of this model. And the accuracy marginally increased from 93.8 to 94.1%, right? And then it again did a hyperparameter optimization, but then there was no change in accuracy. Okay, let's see what next. So it's basically, you see those pipelines getting built over here, right? And it's identifying. So the next best algorithm was a snap random forest classifier. So see, it was 93.3% accuracy as a vanilla flavor, but then it went ahead and it's again doing the same thing, creating those 4 pipelines to do a hyperparameter optimization, feature engineering, and other things, right? Of all these, the best part, if you see here, lies here, right? See this? I can actually see a complete comparison across all these algorithms for the various parameters that I have, right? From average, accuracy to F1 value to precision or area under RC curve, whatever I want to, actually, I can see that. Now imagine you're writing up a research paper, right? And you are trying to sort of put some charts on it, which talks about the various comparative analysis across various things that you have been doing, right? So this is actually a great way to sort of get it started, in terms of how this can really make a lot of sense, right? Finally, it gives you a leaderboard for, which algorithm gave what kind of response. And then it's up to you wherein you can pick up the best one, right? So in this case, I got a 94.1% accuracy as the best one with extra trees classifier. Okay. But then that's actually not the piece, right? What the best piece is yet to come. What I can do is I can actually publish this model, this machine learning of model of mine as a web service. Okay. What it means is my model is published on globally as a web service. Okay. And now I can code that model in my research paper, and other researchers in the similar domain can actually leverage my model to do to run their data on my model, right? So that way, as a researcher, I get to, people quote my, not just my paper, but then also my machine learning model, right? So they can get outcomes from my machine learning model, fit their own data set in the similar domain, right? And so this, I can just simply, publish this from here as a web service from here. Okay. Okay. And what not? What else? What else? Yeah, I can also, do I can actually, this is again a great part, from a research point of view. I can actually publish this entire work, whatever the service has done, as a notebook, as a Jupyter notebook, right? Now see this, I did not write a single line of code, but then the service gave me a proper annotated Jupyter notebook, right? Which is available here in terms of how do I create a machine learning connection? How do you create those pipelines, right? How do I do the pre-processing? All of that is actually, you can see all of that over here, right? And the good part is I can actually download this notebook on my local machine, run it on Google Colab, run it local machine, wherever I want to, or I can actually edit it and I can run it right here, right? So I basically also have that functionality within the Watson Studio, wherein it provides me with the environment to run this Jupyter notebook right here, right? And if you see here, it has again given a runtime to me for 4 virtual CPUs and a 16 GB RAM to run this Jupyter notebook, right? And if you, okay, some issue I think at my end. Okay, it's not able to load the notebook for me, but then otherwise it would have been able to load it, and I could have seen the Python environment over here. I also have a RS Studio embedded in this Watson Studio, where I can run my application. Okay, so I'll quickly go back, and so the important point is, as a researcher, now I have the baseline where I can start with, rather than actually playing with and sort of putting my time into exploring which would be the best fit model for me, right? So instead of doing that, I can actually now um, just a moment. So I can actually now uh, you know um, make this as a baseline for me. Okay, and from that baseline I can always go upwards in terms of doing some kind of improvisations on top of it, right? Okay, so let me again now go back, and I would actually sort of um, try to dig into it. Okay, so let me say I want to do it again, and I will go to that piece. Okay, and say create, and I already have the data set uploaded there. I can upload, as I said, up to 20 GB of data there for this experiment. Okay, let me quickly select it from this project, which I've already given there. We'll find it in the data set over here. Yeah, this is the one. I'll just connect it to here. I'll say no. Now let's try to get into, inside this, try to understand more about this and get under the hood, right? So I'll go to the experiment settings here. Now this is important, right? I could have done multi-class or a regression or time series depending upon, what I want to work with. But what I want to take you through are the various uh, experiment settings that I can actually do. Now, AI is something which is today being assessed from a fairness point of view, right? Whether the model that I'm actually creating is bias free, right? So see this, I can actually try to do a outlier handling and a fairness evaluation for a favorable outcome right from here, either manually or the way I want it to be, right? So let's say I basically want a particular attribute, right, to be checked for fairness. I can always do that from here. Okay, so which is actually very important when you are developing your AI models, right? Similarly, if you see here, this is absolutely fine, no problem. This is what I was talking about. It can give me up to the top four algorithms, in terms of performance, right? It's up to me, and then for each algorithm, it will create all those pipelines for me and, give me those variations here. Okay. Now I can actually, if I have a enough number of data, I can actually do a sequential ordering of my data. By a single radio button, I can actually drop all the duplicate rows, right? I can do a stratified sampling with my data, right? And then I can decide what kind of data imputation I want, right? Whether it should be a median or a mean approach, whatever I want, I can pick from here, right? Um, that's my prerogative. Similarly, um, you know, uh, what kind of a split do I want, right? So that is also available. What kind of split of data I want. But most importantly, see this, I can also leave out a few features from here. So let's say I do not want my model to be biased by gender, right? Whether it's a male or a female, it doesn't matter, right? If they're earning, they can pay. It doesn't matter which gender they belong to, right? So I can always make those improvisations here saying I do not want my model to be biased by gender, right? And accordingly I can change, right? And then I can also change various tuning iterations for my model, right? I can do all of that here. Okay, so i'll I'll stop from here and I will go back to mm, my deck for a while. Okay. So what I was trying to
Hello. Sir, could I interrupt for a moment, please?
yeah, yeah, ma'am, please tell me.
Sir, I am working on multi-class image classification,
Yes, ma'am.
and the dataset is around 10 GB or something like that.
Okay.
So, if I work on this platform and use this auto ML feature, how would it contribute to my research? This is what, if you could clarify.
No, no,
I
no,
mean,
it's not.
the
Okay.
model will be selected by the platform itself. Almost the
Mhm.
hyperparameter optimization will also be carried out by the
No.
platform itself.
Yeah, you're right. What I wanted to explain was you can actually take that down. You can actually take that Jupyter notebook down and you can improvise it with your own code.
And sir, the code that you had told that the Jupyter notebook is generated by here from here by itself, does it follow Python or is it in a specific language?
Ma'am, it follows Python, but then you can always have it this thing. You can always have a different environment to run it as well. By
So
default, it provides with a Python.
this can be used to on a preliminary basis just to identify how should one go about.
I basically covered that only that it basically helps you reach to your baseline quickly.
Sure,
And
sir.
then
Thank you.
you're saying something I'm not able to make out.
Mute कर दीजिए ऐसे, instead of allowing. Yeah.
Oh, okay, okay. I thought there is some audio issue in the. You were saying something, ma'am?
No, sir, that query was well handled by you. My
Okay.
only concern was that how can I quote the outcomes from this platform in a research paper directly and post them as though I did something onto it?
Ma'am, as I mentioned, you can pull down the notebook or you can edit the notebook right there. Okay. And once you have made the changes according to the work that you're pursuing, right? Let's say you're looking to work on a hybrid approach of certain algorithm, right? So you can always make the code, you can edit the code, upload that piece of code that you want to do. And then once you are done, you can again either refresh the web service or publish that model as a web service for others to use. That's what I was
Sure,
actually
sir. And
explaining
is
there.
there any facility for GPU or TPU kind of like we have in Colab?
Mhm. Ma'am, there is a specific provision, of helping the researchers in case they need that in a separate way. Otherwise, the cloud handles the infra for them. They do not need to worry about, how the compute is going to come to them. So that's
And any
abstracted. That's
usage
what is the
limit,
benefit
sir?
of doing it
Any
on cloud.
usage limit?
Oh, yes, there is. So this is all absolutely at no cost, ma'am, right? So that's as I said earlier, for Watson Studio, there is 20 CUH per month. Okay. So what happens is 20 capacity units are per month. What it means is you run your model and you stop it or you pull down the results, stop it. And in case you are exhausted, your 20 CUH, which gets exhausted pretty soon. So either you stop and you hold that meter there, or next month it will again accumulate into your you can again use it. So, and then for different services, this is different, right? For example, for database, that's different, right? For the number of API calls, it will be different, right? So if you're using, let me explain.
Sure, sir. Thank you.
So yeah, so I'm
Actually, my
back on my,
collab limit has exhausted, and now
I
I'm
can,
in search of a platform where I can actually work on my data and code.
yeah. So for example, let's say I'm looking to create a, what should I say? Let's say I'm looking to create a, let's say I'm looking to create a code a chat bot, right? You might have seen that example as well yesterday, right? So each service comes with a plan, right? See this? This is a, for 30 days you can actually use it up to 150,000 tokens, right? For this for free. And again, the next month you can use it. In case you are going for a commercial one, there is some charge associated with it, right? Similarly, if you're looking to use let's say, where is it gone? Let's say you're looking to use a NLP here. What's a natural language? Okay, this is match. Um, yeah. For example, it can be leveraged for up to 1 million record counts with one service instance, right? So depending upon the service, ma'am, there would be a limit there, and but research does not requires too much, of a utilization, right? Unless most of, if you see that this is all about when you go into production, that's when the traffic really goes high in terms of. But cloud, there are certain best practices to always use, particularly when you're not using, and it is applicable to any cloud for that matter, not just IBM cloud, any cloud, right? Similarly, if you talk from a natural language understanding point of view, if you're actually trying to use it, 30,000 NLU items per month is absolutely free. See, and once you go
Yes,
beyond
sir.
that, there is a cost, right? So depending upon, how do you want to structure your, this is actually a great topic, ma'am, when we architect a solution for cloud, that how we should structure the solution so that there is a minimum back and forth between, number of API calls should be minimized so that the cost is minimized for a solution. So it actually comes, so similar is for my research work as well. I hope that answers your question.
Yes, sir. Sure. Thank you so much. Resource optimization is what actually I'm looking forward to.
Sure, sure. So, okay, this was one piece of the conversation I wanted to do. Um, and then I also wanted to talk to you about something. I think, um, okay, this is interesting. So this is, of course, I think you are good with that piece. I want to dig into something very different because I think so far this topic hasn't been covered in the course of this FDP, and it is very, very relevant if you ask me. We all have been working with LLMs, right? And there are some few inherent problems about how do we keep the LLM current, right? Because if it's not current, then the responses that it is giving is again, they are of no use, right? Whatever best technology you put across, it's of no use, right? Again, another thing is, right, how do we actually, which would be the best LLM to start with for that matter, right? And the explainability of that LLM as well, right? Um, so a current situation, right, from a generative AI perspective is there is adoption. Everybody talks about the transformative power of Gen AI, right? At the same time, there are a number of use cases across all the sectors people are looking to explore with Gen AI with, right? Having said all of that, almost all the data, you might have seen a few news clips recently. Few people talked about, few very renowned people talked about that we do not need any more foundation models. We already have enough foundation models, right? Having said all of that, almost all the publicly available data is now represented in foundation models, right? With all those billions of parameters that we have with all those models, right? I'm sure You would have gone through that yesterday when we talked about Flan, Granite, Llama, all of those models, right? And having said all of that, there is still a very small amount of enterprise data which is available in these foundation models, because the enterprise data is something which is not available in public domain. Okay. Now let me give you this example, and then maybe you'll be able to appreciate what I'm trying to refer to. Now, I'm sure most of us who have, we all travel a lot, right? Means we keep traveling, by road, by rail, by flight, or whatsoever, right? On our own, and on we often, tend to buy water, right? Mineral water, a bottle of mineral water, right, to quench the thirst. And had we been in person, right, face to face, this question would have made a lot of sense. But then here, I will be questioning and I'll be answering as well, because there is no way I can seek your answers here. So, a bottle of water actually is available right from rupees 10 to rupees 20 to rupees 60 to rupees 100 to even few thousands, depending upon what brand of water are you buying, right? You can get it for as less as 10 rupees when you're going on a roadways bus. People, some kids will alight in the bus, they will sell those bottles for 10 rupees for that matter, right? You go to any other shop, buy a Bisleri for 20 rupees. You can actually go to another outlet, you'll buy a Vedika, water for some 60 rupees. And then there are so many other options available, right? For a few hundred rupees. And then, the famous water which Virat Kohli is, drinks, is what I've read from newspapers articles, which is like very costly, but then yes, it would have it some. So the point is, it's all water, no? What's so different about these all different kinds of water, right? If I have to again put my question in a different perspective and I leave it open for you to research, right? Normally in labs, we use various kinds of UPSs, uninterrupted power supplies, right? Two major kinds are offline, online. I'm sure most of you in this room would know the difference between the two. So coming back to the previous example of mine, right? So water is just a water, right? How is it different? Now, a water bottle which is coming from maybe Vedika or a Bisleri or others would actually be having some features which are not there in that 10 rupee bottle. And if I have to dissect this problem, I can say that the bottle may be what do we say, cleaned properly, sanitized, before the water gets filled into it. The water, there is no intervention of any human. It's all automatic bottling plants. So the scope of contamination is lesser, and then the quality of water is a lot better. So I can tell all of those things to you, right? Where I'm actually leading you with this conversation is, if a foundation model is trained with enterprise data. Okay, please understand. I'm talking about a model which is actually getting trained with enterprise data. Now, what is enterprise data? Some data which is being generated or used in enterprise, which should be or would be absolutely clean. There would be nothing which is irrelevant in that data. So if it is a enterprise which is catering to medicine or medical clients, that data has all that relevant piece of information from that domain point of view, right? So if that is the case, that means take another example. There is a data from an insurance company, okay, and the model is actually getting trained with that insurance company data. So that means the data is absolutely clean, trustworthy data. And when you train a model with this data, your model is going to be fantastic compared to a model which is trained on public random data. And when you query the two models for a same question, obviously if the query is related to the domain of insurance or medical, this will come with better response, lesser time, more accurate compared to coming from a data from a model which is trained on publicly available data. I hope I'm able to explain my point, right? So that's where is the difference going to be, right? About the kind of data that is basically being used in the foundation model for training, right? And that's what are the typical challenges of a generative AI, because unless you have picked up the best model, that cost can really derail your entire generative AI plans, right? uh, fine tuning, the pre-trained model, right, that you may have will again be a factor there, right? So, computational cost, kind of response time, these are a few things, which can really be a dampener in terms of, or challenges in terms of. Now, where do you start? So the first thing is you start from a model which is something a trusted, number one, number two, which is drawn from the best possible data that relates to the business problem that you're working with. And once you have done that, then you can really, picking up the right model is something which is, which can reduce up to 42 times the inferencing cost for a particular thing, right? And that is where the Granite series of model comes in. I'm sure yesterday you might have seen those models in the session. Those are the models which are actually trained with enterprise data. So that means absolute clean, best performing kind of data has been used to train those models. Hence, the response can be expected to be a lot better, and it is actually a lot better. So I'll actually show you. Please let me skip a few slides. I'll quickly go through. Yeah, see this? The kind of uh, the kind of response that you get comparing a Granite versus any other model would be a lot more better. See this? Enterprise customer actually using for financial company using some other model compared to Granite model is basically a lot more cheaper, and of course the response will be also better, right? That's what I was trying to explain to you in my in the conversation that I was doing. uh okay okay so let me come back to my Watson Studio thing over here. Okay, and this time what I'm going to do is I'm actually gonna launch the other bit of it, right? So I've already shown you the traditional AI thing. I'm now gonna launch it into the Watson X. Okay, and if I actually have to I think you already have seen this bit, but I would just like to explain to you is give me a second. Mm, okay, I think you have already seen this, in the previous one of these conversations. Uh, I'll again associate a watsonx.ai runtime with this. Okay, and I'll go to my assets here. I'll say a new asset. Now, if you see here, when this example you were seeing where you had that opportunity of creating a chatbot in one of these three forms, what I will leave you here with this, with the thought here is, see, these are the various models available, right? What you should really, what I was explaining, the point of view is try to see, assess the same question using llama with a 70 billion instruction set, compared, and then compared the same to maybe a Granite, maybe 8 billion or 3 billion or whatever, and then, and maybe again try to use it with a flan as well, right? And then see the difference in the responses. then as a researcher, you'll be able to appreciate that what a particular model can really do to the response of the query that we're trying to put across, right? So I'm sure when you do that, you'll be able to really be able to appreciate the point of view I was trying to explain to you a while back, right? Uh, okay. Mm. So I'll actually stop here, and I will be happy to take any questions, guys. Any questions? Okay, before I stop, there is some more thing I wanted to talk to you about. Okay, I simply slipped my mind. My apologies. So what I'm actually trying to advocate from all of this was all about something called as Instruct Lab. Okay, wherein you can groom, you can train these LLMs with the kind of data that you want, with the domain specific data that you want using this. And not just that, it also helps you basically work with the synthetic data. And of course, big is not always the good thing, as I was telling you, right? You may actually use a huge foundation model, but then that may not be the right choice for the kind of work we are doing, right? So what we talk about today is a more different kind of approach, wherein you can actually uh, train the LLM with the domain specific information, right? Using Instruct Lab, which is actually again an open source project. You can actually lay your hands on, and that will really help you understand how the model choice of model can really, and then it can also do some synthetic data creation for you. You can actually you can let it know how you want the synthetic data to be generated. And in case you are not happy with the synthetic data, it will come back again. You can give it a prompt and then it'll come back with so many more choices, synthetic data, of course, for you to play with, right? This is based on something called as labs, which is large scale alignment for chatbot. Particularly, this thing is for Instruct Lab, right? You can use it for customizing the LLMs. So I'll stop here, and yeah, if there are any questions, I'll be happy to take them. Okay. Let me see the Q&A or a chat if there are anything there.
Sir, suppose I have a Python file ready with me, Python code,
Hmm.
and the dataset on which I am operating.
Hmm.
So, is there a facility where I can directly run or execute that Python code onto this platform?
Yeah, Watson Studio, no, I mentioned you can actually pull your own notebooks, you can pull your own data. That's what we just did, right?
No, I was just concerned regarding a ready IPNYB file, whether it will be directly executable on this.
Yes, yes, it'll be.
All right. Thank you, sir.
Mm. Okay. Any other question, anyone?
Hello. Hello.
Yeah. Yeah, please go ahead,
Yes,
ma'am.
good evening, sir.
Good evening, ma'am.
Sir, on the site, one option is available is blockchain. On
Where,
the
ma'am?
like AI and machine learning, under the AI and machine learning, Watson X Studio and services are available. So under the blockchain, what services are available, sir? It is not showing on the screen.
Okay. See, um, you might have gone through the Hyperledger Fabric, right? Which is an open source platform under Linux Foundation. Okay.
Okay, sir.
Now, what IBM provided for was something called as IBP, IBM Blockchain Platform. Okay.
Okay,
Now, if
okay.
you remember, in the Hyperledger Fabric, there were two, three components to the solution. One component was an inherent underlying network on which the nodes connected, right? And then there was a smart contract treasure which was running,
Yes,
right?
yes, yes, sir.
So IBM actually provided on IBM Cloud something called as IBP, IBM Blockchain Platform,
Okay,
wherein the underlying network was provided through the platform for the nodes to basically come up. And then, you could deploy your smart contract on top of that. So
okay,
that was that blockchain service, ma'am.
okay, okay, sir. Thank you so much.
Sure, no problem. Any other question for me? Um, okay, if not, then Suyesh sir, I'd like to hand it over back to you.
So thank you so much, sir, for your session and sharing the valuable knowledge. Now it's over to the research scholar uh, for vote of thanks.
On behalf of everyone present, I would like to extend my heartfelt gratitude to Dr. Mani Madhukar sir for delivering such an insightful and engaging session on exploring AI Watson, IBM Watson. Your deep expertise and ability to simplify complex AI concepts have provided us with invaluable knowledge. IBM Watson is shaping the future of artificial intelligence. The real world application, innovative use cases, and practical insight you shared have truly inspired us to explore AI in greater depth and leverage its potential in our respective domains. Your session has not only broadened our understanding but has also ignited curiosity and enthusiasm among all the participants. We sincerely appreciate your time, efforts, and dedication in sharing your expertise with us today. We look forward to more such enlightening sessions in the future. Once again, thank you, Dr. Mani Madhukar sir, for your invaluable contribution. Thank you so much, sir.
Thank you, ma'am. It was a pleasure connecting. Thank you, everyone.
Thank you, sir. Thank you for this